I'm going to go with 22 real quick because I thought that was the easy one. So get through as fast as I can. 22. Yes. I'm going to start with this one because not everybody said it was easy. So the idea here, guys, the idea here is that you got to take the information that they give you. When you start this problem out, the very first thing they talk about is they want to maximize the storage capacity. So that means you have to figure out what's going to allow you to store the most stuff. When you're talking about a cabinet, you're talking about volume. You're maximizing the volume. Okay? You had two cabinets. You had cabinet A and cabinet B. And we want to maximize, now let's use P because it's kind of like what we've been doing with like profit or whatever. Doesn't matter. I believe cabinet A had, is it 12 and 18 cubic feet for both of them? Yeah. So it had 12 cubic feet here, 18 cubic feet there. Then the problem brought up two other parameters. You had X amount of square footage to place the cabinets and X amount of dollars to spend. I believe you had $600 and 60 square feet?
Yeah.
60 and 600 to spend. So cabinet A took up how much square footage? Cabinet B took up how much? Cabinet A cost how much? Cabinet B cost how much? That's how you get the information out of these things. You look at what the parameters of what's left over, of what they're trying to constrain you by, and you break it down into the parts. I believe cabinet A, was it 3 and 6? 75 and 50. Thank you. Okay. So, a couple things you can do right off the bat. To make your lives a little bit easier. Obviously, at this point, we all agree that you can't have zero cabinetry, correct? Yeah. Okay. So, you could cover and solve and get all your intercepts this way. Or, if you want to simplify them both, you can simplify them by GCF. And it's just a little bit easier to work with when you go to solve your systems. What I'm looking at here is this first one has GCF of 3. If I take out a 3, I have A plus 2B less than or equal to 20. Bottom one has GCF of 25. So if I say 3A plus 2B is, what's that, 24? The only reason why I'm doing that is because I don't have a calculator in front of me and I can simplify those values quicker. That's all. You don't need to. We're still first quadrant. We're still going to plot them through that way. We go first quadrant. A and B. Let me look for it. Intercept of 20 and 10. It's obviously moving inward because 0 plus 0 is smaller than 20. Okay. Second one, intercepts of 8 and 12. Oops, sorry. 8 here and 12 here. They ran into each other right there. Again, moving inward. We have ordered pairs. 0, 10, 0, 0, 8, 0, and whatever we figure out this ordered pair to be. Well, that ordered pair is the solution to that. A is 2, B is 9. You will get the exact same result if you went through the larger numbers. It works the same way. I just see, whenever I do problems like this or I see any equations like that and I have GCFs, I take the GCFs out because I think it's quicker to work with because I have a calculator in front of me sometimes and I can do some mental math. That's it. So you substitute all those values in and lo and behold, what ordered pair gives you the correct answer? You want 2 of cabinet A and 9 of cabinet B to maximize volume. Okay. The first one, I really like the first problem. What I don't like are the names of the juices. You have Orangeade and Berry Fruity that uses orange juice and raspberry. So it's kind of confusing for what you have going there. What's easy about that problem though, is the constraint setup. The reason why I believe it's simple for the constraint setup because it tells you right off the bat, you want to maximize your profit. You make 50 cents for the Orangeade and 40 cents for the Berry Fruity. And I believe that's per quart, per gallon. So when we do that, we're going to maximize this at 0.5 of the Orangeade. I think some of you guys use G for orange. This is 21. Now, bless you, we all agree that we're not going to have negative gallons or quarts of juices and things. We know it's got to be first quadrant. But the two constraints that they give you is that they say that you have 125 gallons of the orange juice of OJ, and then you have, 150 gallons of the raspberry stuff. Now, within the two drinks, one of them uses so much orange juice, the other one uses so much orange juice. The other one, with the raspberry, one uses so much raspberry juice, and the other raspberry juice. You're still mixing it between the Orangeade and the berry stuff, and the Orangeade and the berry stuff. Now, here's the quick kicker on this one. You might have heard me mention this before we left yesterday. The mixtures are within quarts. The amounts are given to you in gallons. How many quarts are in a gallon? 4. So I have to multiply both these guys by 4, and I get 500 and 600 respectively. Whenever you're dealing with units of measure, it's always easier to work with the smaller unit because you won't, 9 times out of 10, you probably won't have to deal with a fraction. You won't have to deal with a decimal. Just like when you guys are, if you ever have working with, 3 feet and 7 inches, it's always easier to say 43 inches, okay? Or trying to mix things together like that. So. We can go up to and include, but in the first one, how much OJ does the Orangeade use? It feels like I'm speaking in Igpe Atenlay. Aume, Uchme, OJ. No. The look on your face is like a death stare. You guys don't know Pig Latin?
No. I know that's what you were trying to do.
Uye, Ase, Ederle, N-A, Erdway.
I know there's something that just
You pick the first letter of N-A.
So, we know we're first. Again, we know we have to go first quadrant because we're not going to have negatives. We're still going to do the cover and solves to find our values. I'm going to have my ordered pairs as the orange juice and berry. So this would be my O. Every time I say OR, I want to say O are they? These are my OR scrubs. O are they? Do you know what What movie is that? Come on. Rushmore. Highly recommended. It's one of the best movies. Love that movie. So we go ahead and do our covers and solves. The cover and solves of this one is actually pretty simple. We have what, 500 and wait, hold on. Yeah, 500 and 200.
Yeah, I didn't get this.
Is that moving inward or outward?
Oh, that is inward.
Moving inward. On the other one, I have 400 and 200 for my intercepts.
And it's also
And it's also inward, very good. Which means they ran into each other right there. Ordered pairs you got to worry about then. They're going to be 0, 200, 200, 0, 0, 0, and the mysterious one we have to solve for. Well, a lot of times when we have systems of equations like this, and I see that I can get one of the variables by itself with one step, then I don't have to do linear combinations or any of that stuff, I usually go right to a substitution step. For example, if I look at the top equation, I have 2.5 orange plus 1 berry is 500. That means I can write it as 1 berry is 500 minus 2.5 orange. Then I will take that and substitute it into the secondary equation. 1.5 orange plus 3 times 500 minus 2.5 orange is 600. $1.5 orange plus 1,500 minus 7.5 orange is 600. This gives me a -6, so I'm going to move that to the right side and subtract 600 back. And you wind up with 150 for your orange. Which means if I have 150 for orange, that's my X value. All I have to do is go back 1.5 times 150 and subtract it out, and I wind up with a good old 125 for berry. Now, these are all in quarts. You wind up with the solution does work out to be at 150, 125 for the maximum. But they wanted you to read it in terms of gallons. So to the 150 and 125, what do you have to do? Divide it back by 4. That's about as goofy as some of these things might get. Bless you. Now, the idea for this one here is that if you go back and you just think about what were the two things they gave you to talk about? Well, they talked about orange juice and raspberry juice. Yes, ma'am.
Well, my only problem with it was I didn't know whether to talk about like the different juice brands or like the different flavors or like actual fruits themselves.
When they talk about, when they said that you have no more than those amount of gallons or that many gallons to work with, that should be a red flag, fire engine truck, pulsating alarm. I'm trying to think of a bunch of different analogies. It's not working. Those are your constraints. Same thing when we've talked about you had so many dollars and so many square foot.
I was pretty confident in this one. now. I'm just like.
I'm not gonna lie, these are a lot harder than what everything else is. I love these problems.
So like.
The
Let me.
I know Seb hates these things.
The word problem.
I will tell you guys this all a lot. When you guys go back and talk with Seb about some of this stuff, he's gonna say, I hate this stuff.
He'll just say
Yeah.
he'll just say
Listen,
no.
I like got the word problem like 2 nights ago, but like last night I was just like.
And you know what? This is the push. This is the stuff that gets a little bit trickier. The last one is really the most difficult. And it's the most difficult because of the one last little piece that they give you about that 3 times as much as something else. Yes.
How many questions are quiz?
I think it's like 6, 7 total, maybe 6. Couple word problems, some graphs, some equations, nothing too crazy. All right. I don't know. I haven't finished that.
So for the last one we did, what was the order?
150, 125, but then you have to divide them both by 4, and I think you get 37 and a half and something else.
31
And a quarter. Yeah, 37 and a half and 31 and a quarter.
Completion points.
Is there anything we can do for the bid?
I have some more problems for you. Last one. You're talking about the tomato sauce and salsa. And it wants you to use so many tomatoes and so many onions to make a profit. And it asks you to maximize your profits. So if you're making tomato paste and salsa, or tomato sauce and salsa, and I think it told you make $2 on your tomato sauce and you make $1.50 on your salsa, that right there is your objective function. Your profit is to make $2 per tomato sauce and $1.50 for your salsa. And I apologize, I'm trying to make my S a little curvier and my 5 a little more rigid. Isn't that what a cursive S looks like?
No,
It's like
Oh, sure.
yeah, it's sideways.
Anyway, now when you reread that question and you're trying to figure out your parameters, it tells you you have so many tomatoes and you have so many onions. You have up to using, 180 tomatoes?
yeah.
And you have up to and using 15 onions. So now, if you have so many tomatoes and so many onions, well, the tomato sauce uses how many tomatoes, and the salsa uses how many tomatoes. The salsa uses how many tomatoes, the tomato sauce uses how, I got lost in what I'm saying. Let me rephrase that. The tomato sauce uses how many tomatoes according to the problem? 10. The salsa uses how many tomatoes? 5. Do you see how I'm using the mixture of both of these problems with how many tomatoes they use? I go to the same idea with onions. The tomato sauce uses how many onions? 1 onion. The salsa uses a 1/4 onion. Can you have negative stuff? But the one thing it says is that you want to sell 3 times as many tomato sauces as you do salsa. So if I sell 1 salsa, how many tomatoes should I sell? 3. So this is the weird inequality because he wants to be, I think it says at least then or something on that. For every 1 tomato, you have to multiply the salsa. That's the tricky part. There are very, very few problems that we wind up with that have intercepts both at 0 that you have to kind of draw the diagonal into. Now, what's nice about this problem, well, I wouldn't say super nice, but the graphing of the first 2 is really easy. Cover and solve, it's really quick. What gets messy is where to place this. And let me walk you through how this winds out. So we have tomato, salsa. Intercept at, 18 and 36. Cover and solve. Bless you. Obviously moving inward again. The next one I'm at 15 and 60. You okay with that? 15 and 60. Sorry, it's not really drawn to scale very well. Now, before I put in the very next value, the next line, I'm going to find that intersection point real quick. Okay? And it's very easy to do because I can say the following. T is 15 minus a quarter S. Just by using substitution, just by moving it over. Are we okay with that? And then I would go through the process of solving that out. 10 times 15 minus a quarter plus 5 is 180. It's 15. I'm 2.25s. So you have 150 minus 2.5s plus 5. Sorry. Which means I wind up with 2.5 equaling 30, and I believe that's 12. Pretty sure that's 12. No, because I subtracted the 150 over, and then I have negative 2.5 plus 5 is just 2.5. And then a quarter of 12 is 3. 15 minus 3 is also 12. So this point here is at 12, 12. And it's also moving inward. Now, what happens is you start to figure out where do you place that other value. It's at 12 if your t value is, if your s value is 12, the t value would be 36. So it would be way out there. What I'm saying is, if it's 12 here, this will be out here. So it winds up being something crazy like that. That deals with this one. I will not put that like that. I have the doll sheet and the candy bar one. I'd like you guys to try those two. They're a lot easier. This one's a pain in the butt. It's the bottom two on your way out. Give those a shot. If you got a question, stop by in the morning. We'll quiz this stuff tomorrow, and we'll have some new stuff on Monday. Watch that. Do the bottom two, the bottom two, the bottom two. No, they still have not given us any flex passes. I don't know why. We'll complain downstairs. We've been emailing all week. And they don't like the math department. Do you blame them? There you go. The bottom two. Yes, look at tomorrow. Oh, you got one?
I can't. Let's go and see filming on. Daniel, I'm taking my time, but not what I'm doing. I will.
Yeah, I've learned that I get yelled at if I don't hole punch stuff. So I hole punch it. You grab one? You grab one? You grab one? You got it, I know you grabbed one. See you later. Bottom two, sir. Thank you. Thanks for the help with the chairs, I appreciate it.